Okay, next we will do problem number 3 from section 2.2. In this problem we have a linear transformation t from R2 to R3 defined by t of a1, a2 as the vector a1 minus a2, a1 and 2a1 plus a2. We're also given three bases. Alpha and beta are ordered bases of R2, and we're given gamma as a given ordered basis of R3. Okay, now when this problem has two parts, in the first part we will compute the matrix of the transformation T relative to the bases beta and gamma, and in the second part we will calculate the matrix of the transformation T relative to the bases alpha and gamma. Okay, so in the first part, what we do is we first write down the vectors in beta, and then we work out t of these vectors, and then we work out the coordinate vector relative to gamma of each of these, and this will form the matrix that we want. Okay, so we first work out t of 1, 0. Okay, so we put a1 equal to 1 and a2 equal to 0 in the formula here, and that will give us the vector 1, 1, 2. Now we also need t of 0, 1. This time we put a1 equal to 0 and a2 equals 1, and we'll get the vector minus 1, 0, 1. So we have to work out two coordinate vectors, one for this guy and one for that guy there. Okay, so first of all, we'll do the first vector. Okay, so we want to express the vector 1, 1, 2 in terms of the basis gamma. So what we will do is we will solve this vector equation. x1, 1, 1, 0 plus x2, 0, 1, 1 plus x3, 2, 2, 3 equals the vector we know, 1, 1, 2. Okay, now by looking at the three components of both sides, we'll get three equations. In the first component we'll get x1 plus 2x3 equals 1. In the second component we have x1 plus x2 plus 2x3, and we want that equal to 1. And in the last component we have x2 plus 3x3 equals 2. Okay, so here we multiply the first equation by minus 1, add it to the second. Okay, so our new second equation will be x2 equals 0. And we have these three equations. The second equation tells us x2 is 0. The third equation tells us that x3 is equal to 2/3. And the first equation tells us x1 is 1 minus 2x3. Sorry, 1 minus 2x3, which is 1 minus 4/3, which is minus 1/3. So the coordinate vector of t of 1, 0 is the coordinate vector of 1, 1, 2, which we've calculated to be x1 is minus 1/3, x2 is 0, x3 is 2/3. Okay, so next we need to calculate the coordinate vector of minus 1, 0, 1. So again, we solve a vector equation. This time we want to express minus 1, 0, 1 in terms of the basis vectors in gamma. Okay, so we look at the first component again. We get x1 plus 2x3 equals minus 1. Second component, x1 plus x2 plus 2x3 equals 0. Third component, x2 plus 3x3 equals 1. Okay, so again we multiply the first equation by negative 1 added to the second. And we'll get x2 equals 1 plus 0 is 1. Okay, so this tells us that x2 has to be 1. The third equation tells us 3x3 is 0, so x3 is 0. And the first equation tells us x1 is equal to negative 1. Okay, so that means that the coordinate vector of t is 0, 1. Sorry, that should be a gamma. Is the coordinate vector of minus 1, 0, 1 with respect to gamma. And we calculated that to be x1 is minus 1, x2 is 1, and x3 is 0. So that means that the matrix of the transformation t relative to the bases beta and gamma is, the first column is minus a third, 0, 2/3, and the second column is minus 1, 1, 0. Okay, now we move on to the second part of the problem, and in the second part of the problem we calculate the matrix of the transformation t relative to the bases alpha and gamma. Okay, so the first step is write down the vectors in alpha, 1, 2, and 2, 3. Then we calculate t of each these guys, and then we work out coordinate vectors relative to gamma. Okay. Alright, so it might be helpful to write down the formula again. T of A1, A2 is A1 minus A2, A1, and 2A1 plus A2. Okay, so we put A1 equal to 1, A2 equal to 2. So T of A1 is minus 1, 1, and then 2 plus 2 is 4. Okay, so this time we need to express the vector minus 1, 1, 4 in terms of the basis gamma. So we solve the vector equation x1 times 1, 1, 0 plus x2 times 0, 1, 1 plus x3 times 2, 2, 3 equals minus 1, 1, 4. Okay, again by looking at components, this gives us the system of equations x1 plus 2x3 equals negative 1, x1 plus x2 plus 2x3 equals plus 1, and in the third component, x2 plus 3x3 is 4. Okay, again we multiply the first equation by negative 1 and add it to the second. And we get the equation x2 equals 2. Okay, so this tells us that x2 has to be 2. The third equation tells us that 3x3 is 4 minus 2 is 2, and x3 is 2/3. And the first equation tells us x1 is minus 1 minus 2/3. Sorry, minus 1 minus 2 times x3. which is -1 minus 4/3, which is -7/3. So the components of our coordinate vector are -7/3, 2, and 2/3. Okay, so we write that down. So coordinate vector of t of 1, 2 relative to gamma, which is the coordinate vector of -1, 1, 4 relative to gamma, is the vector -7/3, 2, and 2/3. Okay, so this brings us to the second vector in alpha, which is the vector 2, 3. So we next calculate t of 2, 3. So this time we put a1 equals 1 and a2 equals 3. And we get -1, 2, and the last component we have 2 times 2 is 4 plus 3 is 7. So we need to calculate the coordinate vector of this guy relative to C. So we need to express that vector in terms of the vectors in gamma. So we solve a similar equation again. Okay, so now our system of equations are x1 plus x2 plus 2x3 equals -1, x1, oops, that first equation is wrong, there's no x2 there. Okay, in the second component we have x1 plus x2 plus 2x3 equals 2, and in the last component we have x2 plus 3x3 equals 7. Okay, so again we multiply the first equation by -1, add it to the second, and we get on the left hand side x2, and on the other side we get 1 plus 2 is 3. Okay. Alright, so this means x2 has to be 3. The third equation tells us 3x3 is 7 minus x2, which is 4, and that means x3 is 4/3. Okay, and the first equation tells us x1 is -1 minus 2x3, so that's -1 minus 8/3, which is minus 11/3. So our coordinate vector of t of 2, 3 relative to gamma is the coordinate vector of -1, 2, 7, and we calculated that to be x1 to be -11/3, x2 to be 3, and x3 to be 4/3. Okay, so these two vectors here are our coordinate vectors that we need to put into our matrix. So finally, the matrix of T relative to the bases alpha and gamma is the matrix with first column -7/3 to 4/3, and in the second column -11/3, 3/4. Okay, and that's the end of our problem.